Welcome, everyone. Good morning, good afternoon, depending on where you are around the country. My name is Nathan Heston, and I'm joined by my colleague Daniel Daniel Moyer. Good morning, Daniel.
Good morning, Nathan.
So we are going to be discussing battery energy storage and generator integration design considerations. We'll be essentially talking about how you can integrate a generator into your ESS system. So as we get started, we do want to note that this is a NABCEP approved talk. So if you're here for those continuing education credits, please stay through the end. Send us an email. Let us know how your name should appear on your NABCEP certificate. We'll check the attendance logs, and then we'll issue those certificates. Daniel, you will be monitoring the Q&A, so please stop me if we've got good questions coming in.
Yeah, absolutely. The chat has been disabled, but Q&A is still open. Please put your questions, comments in there, and we'll address them.
Great. So let's go ahead and get started. We're going to start off here by reminding you that there are conferences that we show up to, and Daniel and I often go to these conferences. NABCEP, the Continuing Education Conference, is all about learning. So courses like this one will be at NABCEP. Daniel, what will you be talking about at NABCEP?
Building codes and fire codes related to energy storage, specifically NFPA 855.
And going to that NABCEP conference, yes, there is a fee to that, but you can also get a number of continuing education credits by sitting through those courses that are there. You get credit for your attendance and your participation. And I like that conference so much. I always come away from NABCEP feeling like I learned a bunch and don't know enough. And then Intersolar is coming up as well. That's down in San Diego at the end of next month. So in about 1 month from now, we'll be there. And Daniel, you've got a QR code on the screen.
That's right. Anybody who wants a free expo pass, go ahead and scan that QR code or email us, and we'll get you the link to get a free expo pass. It's not the conference pass, but an expo, and you can walk the floor and come visit us. Anybody who comes by our booth, Nathan and I will be sure to have a special gift for you.
Yes. So please utilize that. Come join us in Intersolar and let us cover that Expo Pass ticket. So there's a QR code on the screen. Additionally, we are going to be sending out these slides. So if you want to access the QR codes after the talk, feel free to wait until you get those slides. They'll be coming from our training email address tomorrow, and you can use the QR codes at that point as well. I want to point out that Daniel and I are both employees with Briggs Stratton Energy Solutions. Briggs Stratton acquired Simplified Power several years ago, 3 years ago, and Daniel and I were with Simplified Power. Simplify has been making LFP batteries in Oxnard, California for a decade and a half now. And Briggs Stratton really brought to the table major manufacturing around the world. So a lot of different facilities around the world. Of course, Briggs Stratton is known for their engines, their generators. It's also a quite old company, Daniel, established in 1908. So it's sold in more than 100 countries. To give you an idea, my wife is from Ghana in West Africa. We have a Briggs Stratton dealer in West Africa there, and probably in many other countries around the world, over 100 countries. It's owned by KBS Capital Partners, so it is a private company. And we have a regional headquarters. We have 40,000 servicing dealers worldwide. So Briggs Stratton is quite a large company, and Daniel and I are in the Energy Solutions division, which focuses on generators and batteries, the topic of today's training. We will be talking a decent amount about SolArc inverters today. We have a partnership with SolArc to develop energy storage systems together and deliver energy storage. And we will be discussing how to program SolArc inverters when you are integrating generators. Though we do focus on the SolArc software in today's training, much of what we're talking about is somewhat a standard throughout the industry. The topics, etc., do apply to other inverters. And, our batteries can work with any inverters capable of doing LFP battery settings. So if you have not done an energy storage system with Briggs Stratton before, if you're a licensed installer, are eligible for $1,000 back on that first ESS system. So you get this ESS purchase bonus once you buy your first ESS system. And then, Daniel, they can also sign up for what else to get these battery rebates?
A part of our Elite IQ Installer program. So just to be clear, anybody can get the $1,000 off their first install after you've done your first install. Reach out to me, reach out to Nathan. We'll get you signed up for the IQ Installer program, and then you get $100 off every battery you install going forward, plus other benefits like we'll put you on the locator maps, and we have other newsletters additionally, as well as we'll send you some swag.
Yeah, and this is our way of locating. So when you join our installer qualification program, our IQ program, this is our way of directing leads, directing our customers to installers in their areas. So please do reach out to Daniel and I, get yourselves on the map, get your company on the map if you're going to be installing these systems. Plus, take advantage of these rebates. $100 per battery module adds up. You do 10 systems in a year, 3 batteries each. That adds up to a $3,000 check. Those get paid out quarterly. So let's jump into the basics as we talk about energy storage systems. The key word in an energy storage system is that storage, and what that means for us is a high quality battery, right? So in order to be able to leverage energy storage in your home, essentially that means a battery. I always get questions when people figure out I'm a physicist about having some kind of elevated water tower or suspending weights from a string. These systems, really, the amount of energy that a lithium battery holds is just quite incredible. And I like to give the figure that if you were to fill your house with water, one of these batteries can lift your house full of water up 10 feet in the air. That's how much energy is stored in them. So there's a lot of energy in these lithium batteries. The LFP batteries are also the safest of the lithium battery chemistry. So we'll be talking about that. We'll be talking about how easy it is to install these 6.6 kilowatt hour batteries. So what you're looking at, that 3 stack in the bottom left corner, that's 20 kilowatt hours of energy there. Also needed for an energy storage system, of course, batteries are DC, is an inverter, some way to take that DC electricity and convert it into the type of electricity used in our homes, right? AC electricity, 240 volts. And what that inverter does is it manages the flow of power into and out of the battery, into and out of the grid, and to the home's loads. And it does that with software, and we'll be talking about how to do some of that programming with software. What you can also do with an inverter, of course, a hybrid inverter like is on the screen, is integrate solar. So there are 3 independent MPPTs built into a Solar 15K, which is being shown. And those allow you to bring 3 separate strings of solar that get regulated differently, that get optimized differently to charge the batteries, but we can of course, integrate a generator. And a lot of customers are putting generators and batteries together to kind of capture the best of both worlds. And Daniel, you often compare this to driving a hybrid car, right? You have the benefits of a generator, but you also have the efficiency that batteries can offer, right? And
Yeah, in addition to having the inverter, which can take the DC, turn it into AC, the Solar has a battery charger, right, that can take AC that's coming out of the grid, AC that's coming out of a generator, turn that into DC and charge up the battery as well. And Nathan, a lot of times this has been historically what we've done in off-grid systems. You would just get rid of that little grid icon, and if the grid goes down, that's essentially what you are. You're an off-grid home.
Yep. And you could, even without the solar, you could run off that generator, use that to charge the batteries up, and then run on those batteries until the batteries get low, and then start that generator back up again. And in that way, you're optimizing the amount of energy you're getting out of the generator. You can run it at a high efficiency. You're going to talk about that later in the talk. And then coast off those batteries like you do in a hybrid vehicle. So the traditional way of backing up homes is what you see on the left side of your screen. What you see there is your load center. You see a transfer switch connecting either the utility through the meter can or the generator, right, to the loads of the house. And so essentially what that generator is doing in the typical backup system is it's waiting for the grid to go down. If there's ever a grid outage, then the auto main sensing of the generator will start up. The transfer switch will switch over to the generator and then connect the generator to the loads of the house. So that's the traditional generator style backup of homes. What are we looking at on the right, Daniel?
That hybrid car example. So if the grid were to be lost, on the example on the right-hand side, the generator would not necessarily start right away. The transfer switch is built into the Solarc. It would start to use energy stored in the batteries to power the home loads. If, and we're going to talk about this, the battery starts to get low, we can automatically start that generator, take over the home loads, and start to charge up that battery.
Great. One of the things to compare when we're looking at generators versus batteries, and we're going to talk about generators plus batteries here in a minute, is, what essentially is a battery in the generator world. So if you're used to a fuel tank, like a propane tank, or maybe you just have a utility supply of natural gas to your home, if you're used to a tank like that, essentially the batteries are a tank, right? But they are generally a smaller tank. You're looking at 20 kilowatt hours of energy stored in that tank. And, if we're looking at a 100-pound propane tank, there's a lot more usable energy in that propane tank. The other thing to compare when we're looking at a generator versus a battery is what is turning the fuel into usable energy, right? So DC electricity is not immediately usable by the home, by most loads in the home. And so what we need is an inverter to convert that electric fuel, the DC electric fuel, into AC. And so in many ways, the inverter is like the engine of a generator system, or maybe the alternator, really. And the fuel tank, is very similar to the battery. So I like this analogy. I think it helps most customers who are quite used to, fuel tanks in cars and engines to understand what a battery and an inverter are. Inside an inverter, now it's different depending on what model you're looking at. We are showing a Solarc 15K here. And on the left side of the screen, you're looking at the DC input side. That's the battery connection side. You can see dual battery connections there, both with their own 200 amp DC, so it's 48 volt DC breakers. And so those dual inputs there are going to be connected to your battery. And if you are going to take advantage of the full power input output of a Solarc 15K inverter, you'll want to use both of those because you'll be pulling more like 250 amps of current. And so if you're only using one of them, you'll be limited in power. Additionally, in the center of the inverter there, that's the accessories bar, the communications hub of a Solarc inverter. And so the accessories bar there, that's where you're going to connect things like CTs or two-wire start or emergency stop. And if you have multiple inverters in parallel, you can parallel up to 12 of these. You have multiple inverters in parallel, you'll use those paralleling communications connectors there. Those are RJ45 Ethernet connectors. That allows you to get more inverters if you want to do that. Our batteries are communicating batteries, and they'll plug in through the battery CAN bus port that you can see there as well. And then, Daniel, what are the orange cam lock tabs there for?
Yeah, those are our 3 independent MPPTs, and each of the MPPTs has the ability to parallel up 2 strings. And these are great if you, say, for example, have solar modules on east, south, west facing roofs, that you're not going to be limited by the production of each string as the sun moves across the sky. Nathan, we did have a question.
Yes.
Mark's asking, keep them coming, everyone. So an automatic transfer switch is not needed with the Solarc?
It is not. And in fact, the beauty of using a Solarc, and I'm going to go back here, the beauty of using a Solarc is it's got a generator port. And additionally, when you have batteries, you get millisecond transfer time. So instead of seeing the clocks reset, the internet connection go down, people look up from their phones, you have uninterrupted, essentially uninterrupted electrical service with a Solarc. So it's got these interconnection transfer switches that are inside the Solarc are really relays, large relays. And it's got a separate generator port. Now, there might be a desire for a transfer switch still, and Daniel and I will talk about that later. So if you have, I was just helping an installer yesterday with an AC coupled system and a generator, what you can do is you can use a transfer switch to bring either utility or a generator, kind of like on the example on the left, into the inverter. through the utility port. And so let me go back to those ports and then use the gen port for other things. So let me point out the AC connections on the Solarc. So you absolutely can get by without a transfer switch if you're using a Solarc. So one, you have the grid input. This is your utility input here. It's 200 amp rated. You have your load output. This is your going out to your load center. This is 200 amp rated. There is a 200 amp disconnect up there at the top. And then you have your generator port here. And this generator port is protected by a 100 volt or 100 amp fuse. It's 80 amps of continuous power that it's rated for. So that's 19.2 kilowatts. And you could bring a generator in through this AC port. So you've got L1 and L2 there, 240 volt generator. It does need to be 240. Okay. Alternatively, you could bring AC coupled solar in there. So you could bring in 240 volts of maybe N-phase microinverters or a solar edge inverter that's already existing on a site. And so you can use this generator port for other things. We're going to be talking about using it as a generator port. But if you already have AC coupled solar on a house, you can use the Solarc to control that and keep it active even in a grid outage. So we'll get to that. I do want to point out that, when you're considering with your customers how to back up their homes, there are advantages to generators, right? You get essentially unlimited fuel or unlimited runtime. There are lower upfront costs. Generators are typically a little bit less expensive. They're also not dependent on solar insulation, meaning that, you don't have to worry about the shading as much, or if you're in a place that has poor weather conditions for solar. Generators work great. They work day or night.
Winter or summer as well.
Winter or summer, as long as you get those cold weather kits. I've seen some customers that are in very cold locations talking about generators not running, of course. And if, but the con is, of course, generating electricity with diesel or propane is gas or propane. It can be expensive, right? It's expensive, and Daniel, you'll get into those costs a little bit today. Also, you have to do engine maintenance, right? There are engines to take care of. There are batteries that will be needed to change over the years. Installation location, you are going to be limited in where you can put this. You don't want to put it under your bedroom window. And we're going to talk about where to put it. And of course, they're a little bit noisier. Now, our Briggs Stratton generators are relatively quiet compared to what you would think with a typical portable system. And then there are things like zombie boxes, et cetera, that you can integrate that can really quiet your generator down. But energy storage is essentially quiet from the get-go, right? Electricity is quiet. They're eco-friendly. You can get a 30% tax credit off an energy storage system, even if it's just batteries and inverter, just battery backup. You get faster overall transfer time. That's why I was talking about milliseconds instead of qualifying a generator signal. Again, they're silent. You can save money on your energy bills. And if you're using solar, you can get electricity for free after that upfront cost of the solar panels. You can generate all the electricity that they can output with solar, and adding batteries to a system allows you to store that energy, have somewhere for it to go as well. So if you're not on a net energy metering plan, as is becoming less and less existent around the country, batteries are needed to get a return on investment. They are a little pricier up front. They cost a little more. And you might have to do a little bit of work relocating some of the loads depending on the size inverter you use or the side of the loads in an electrical home. And you have more limits on your overall energy, right? So you can pull out a certain amount of energy. The 15K will do 12 kilowatts continuously from batteries. But you have more limitations on your overall power.
Nathan, we have a slew of questions, and I really like this because this is going to open up the conversation to where we're interested. Conrad's asking, what size generator is possible on the Solarc 15K? You mentioned it a little bit, 80 amps continuous on that gen port. That's 19.2 kilowatts. What about on the grid port, though?
Yeah, you could do up to 200 amps on the grid port. So you have that 200 amps of pass-through there. Briggs Stratton makes the largest, the highest power output generator on the market for air-cooled, which is a 26K generator. So it's just a little over 100 amps. I think it's 107, Daniel, for a 26K.
Yep. And I put a 125 breaker in there.
Yep. And so that can be used that could be used on the grid port. You will need it, if you're not off grid, you'll need a transfer switch to either have the generator on the grid port or have the utility on the grid port.
Next question from Andy. Thank you, everyone. Have you had much feedback about the challenges of connecting battery cables, communication cables, DC power for energy track in such a small place in the controller? I think they're referring to the top
Yeah, so they're talking
controller.
about our 6.6 controller, and I will say yes, we'd like to make that bigger. And so we are continuously wanting feedback on those kind of things. So keep them coming. I have done a bunch of these systems myself, and I too would like a little bit more room. Now, can I make it work? Absolutely, right? And compared to some other systems, I find it quite adequate. But yes, we would always like more room. And I think as installers, we know that, dropping a screw down in there or, just trying to get terminals threaded, that kind of thing, can be challenging. And so we make continuous improvements on that. And I did want to add one more thing about generator integration. I mean, there's no reason you couldn't put a 26K on the 80 amp port on the Solarc. You could just limit how much power you're going to pull from that port, right? And so you just wouldn't be able to pull all 26K. You'd be able to pull 19K through the generator port on the Solarc.
Kevin's asking, what if you have a 400 amp service? Nathan, we could do 2 Solarcs in parallel.
Absolutely. Let's see
would
if
we
I
have
can go
a,
up to, yeah,
could
so
we
if I
feed
had
the
multiple,
generator into one?
yes, you could. Well, you split off the generator. So we're
Yep.
going to talk about feeding each inverter with a generator. And so if you have paralleled inverters, you need to feed both gen ports, not just the port on one inverter. So you could always add, so you've got 200 amps of pass through with each inverter. You could always add a second inverter and go up to 400 amps. So that's a great question. And with 400 amp service, I doubt a single inverter, which is capable of 12 kilowatts, would really cover the home's load. So you would want to use 2 inverters, or you might want to split off some of those loads that you don't want in a grid outage situation. So great questions. Keep them coming.
Mark is asking, what about Symphony Power Management? And he acknowledges that if we're gonna address this later, don't address it now. So we are gonna talk a little bit about this. Eric's asking, so you can't have solar and generator connected within Solarc at the same time?
Oh, you absolutely can.
And we're gonna talk about that, how we can use an automatic transfer switch. Let's keep it going. I think the takeaway on this slide is, right, you're going to reduce the fuel, maintenance, and fumes that come with running a generator. Reduce, not remove, but reduce them. Next slide.
Yes.
Thank you.
Good, Daniel. And I want you to talk about this. I do want to address that question. Absolutely. You can have DC solar and a generator running to charge your batteries at the same time. When you are doing AC coupled solar, you don't want both of those devices running at the same time. Because you don't want that generator getting backfed from the microinverters or the AC coupled solar. And so we're going to address a way that you can block them out. But typically, if your solar is producing, your loads should be covered from that solar. So there would be rare instances, such as very early in the morning when the solar is weak, and in the evening when the solar is weak, with AC coupled solar, where you would have to shut off the solar in order to run the generator. But with
Right,
DC
John
solar,
Cromer has explained it, right? The solar can be either grid following or grid forming. So when it's running off of batteries, the solar is a grid forming, which can then adjust the frequency of the sine wave to curtail AC coupled charging. But when we start up a generator, it's a grid following inverter. So that removes our ability to adjust the sine wave to curtail. So I think we're going to show that.
And I don't want to pollute the conversation more, but
Yeah.
there's a big difference between AC coupled solar and DC coupled solar. So when I bring solar strings directly into those orange cam lock ports on the Solarc, the orange and green cam ports, that's DC solar, and it can be on at the same time as the generator. It's just going to charge the battery. It's not going to cause problems with the generator. So I can use generator power, and if I just have weak DC solar, those two can complement each other at the same time. The challenge comes when we start talking about AC coupled solar, which is when we already have inverters on the solar panels and they're kicking out 240 AC. Then we have to bring it through the gen port, and we don't want to have the generator on at the same time. So hopefully I clarified. Daniel, what are we looking at on the screen here? And what do we want to talk about here?
I think some of the takeaway here is that when you are running a generator, most of the time you're going to have maybe a 26 or an 18K generator. A lot of times the amount of power that your home is consuming is nowhere near that amount. We oversize the generator for motor start load capability, for example. A lot of times, and if you look at the histogram, which is kind of a little chart inside of the generator's controller, it tells you what percent load the generator has been running at historically. And a lot of times it's a half load or a quarter load. So
Yeah, you'll
what
see
I'm
30% as an average fairly frequently, right? Which is a lot like having your car stuck in traffic in town, right?
Yeah, so what we can do is rather than kind of idling in traffic, we can kind of run the engine at a higher RPM, if you will, at a more fuel efficient point. And you can see on the chart right there, what I'm showing you is the fuel consumption at a given load. And it's not a flat curve. Advance one slide, Nathan, please.
Yeah,
Oh,
sure. So
one.
I mean, obviously when you put the pedal down, you're going to be burning more fuel, right? So it's not like running a heavier load on a generator is not going to cost more fuel. It does, but you're going to get that highway mileage to
Yeah.
really put my metaphor to use, right?
And this, I think, is just showing you how much propane costs, right? The average in the country, and people, please put in the chat or the Q&A how much propane costs for you. But if you're running a 20K generator, even at half load, 2.31 gallons per hour, you run that all day, you're using about 55 gallons of propane. That's over $100. Even if you're running at quarter load, you're still getting close to $90 of propane you're using. So the idea is that we're going to run the generator for a shorter amount of time, charge up that batteries, and then shut the generator off, saving money, key
On
there,
fuel.
and also saving
Yeah.
the noise that comes along with it as well. A lot of numbers on the right. We're going to send these slides out so everybody can get the look at it. But
But
again,
essentially
the
what we're looking
takeaway.
at here is a lot more kilowatt hours per gallon. And that's what, that's what you're after is having the electricity when you need it, even if the sun's not shining, right? But not having to spend a fortune in fuel to get it. So we're not going to be idling that generator when we've just got 2 kilowatts running inside the house and we've got a 26K burning away on fuel, right? So we can make it a more efficient system by adding batteries. So that's that hybrid car example that Daniel uses. What's this looks like, are we selling Craftsman generators, Daniel? What are you showing this for?
That is one of our portable generators. So you can, I get this question a lot, Nathan, is can I use a portable generator to feed into a solar arc? You can. It
Yep.
does need to be a 240 volt generator. Keep in mind, you're not going to have that two-wire signal to start that we're going to talk about here to automatically start and stop the generator based on the
But you can
state
buy
of
kits for
charge.
those, can't you?
You could, yeah.
Some portables you can get kits for, and notice that is a Briggs and Stratton. You've got that logo on there. We've got one of our engines in this. This is a portable. This one is a gas one, Daniel.
Yeah, gasoline, and there are some ones that can run on propane, even tri-fuel ones. A lot of times you can put a twist lock on the outside of the house. Keep in mind a little bit when you are using a portable, don't let the fuel sit in there. You might need to use stable. Another thing to keep very close attention to is the instructions on the portable. We'll talk about whether or not you have the bonded neutral or floating neutral. And when you use a portable to do a whole home backup, you need to pay close attention to that rather than just running extension cords through your house.
That's a great point, Daniel. I appreciate that. We're going to talk about some of the programming, and I do want to point out that not all portable generators are going to work. So Daniel mentioned it needs to be 240, but some of them, especially some of the cheaper ones with the poor signals coming from the alternators, might not be accepted as an appropriate sine wave in your inverter. So the inverter will allow us to do some expansion of the frequency, the acceptable frequency range, etc. But it still needs to follow grid standards. And so we'll talk about expanding that frequency range a little bit. If you're off grid, it is easier, but not all portable generators are going to work. Now we're showing you here a standard wiring diagram showing a Solarc 15K with a generator coming in on that 19 kilowatt gen port that's there. We are showing a two-wire signal to start running to that generator as well. And then this is an example where we're looking at all the loads in the house being backed up. So this is whole home backup with a 15K. This is kind of the most common wiring example here. You've got your batteries, you've got your generator, you've got the main load center of the house, and everything is being run through the load port on that Solarc. In order to connect the generator, we would be using the two-wire start functionality of the inverter. And so what that does is it allows you to set a start percentage on the batteries. So you might want to keep a battery reserve and then start up that generator when the batteries hit that level. So let's suppose we want our batteries to keep a reserve of 30%. Well, when the batteries get down to 30%, it'll automatically start up that generator using the two-wire start functionality. So in the Solarc, it's a normally open dry contact, meaning it's not supplying any current. It's just connecting pins 7 and 8 when it wants the generator to start up. So on a Briggs and Stratton generator, we would utilize pins 4 and 5. So we're showing it on the vertical 13K on the right, and then the horizontal 26K power protect units there. So it's pins 4 and 5. And we also will need to disable the auto mains sensing. So Daniel, can you talk us through that?
Yeah, of course. When a generator only system is in operation, we got a generator and a transfer switch. The generator is the device that's looking for the presence of grid sensing. We need to be feeding power to the generator, not only for that grid sensing capability, keep any cold weather kits that are maybe on there, and also keep the starting battery inside the generator charged up, ready to go. If you don't do anything and the generator sees the loss of utility, it's going to start up and then send the signal to transfer and transfer the house. What we're going to do, though, in one of these hybrid systems, we're going to actually locate the power that's feeding to the generator in the backed up loads panel, because we want to make sure the generator still is warm, it still has its battery to charge. If we do that and the home goes into an off-grid situation, the generator's still going to see the presence of grid.
Power,
it's just
right?
yeah,
it's going to see it coming from the batteries,
from
right?
the batteries. So what we need to do is go in there, do a couple adjustments right there. Well, I'm not going to explain it. Get in there, adjust it so that if it still sees the presence of grid and the presence of a two-wire signal start, it will start up.
Yeah, so that's what we're going to do with, disabling the auto main sensing is going to allow that generator to respond to the two-wire signal to start, and it allows the inverter to start and stop the generator based on the programming that you do. Now, on the battery charge settings for the inverter, what we can do is we can tell the inverter to start up, and what I'm showing on the screen in the center there with that red box is we're going to tell the inverter to start up the generator anytime the grid is down and the batteries get below a 40% state of charge. So it doesn't have to be 40. You can set it what you want to. A lot of customers will do a 30 or even a 25 and keep the generator off longer, use that battery power that you've got. The 40% there is when the two-wire signal to start gets sent. Now keep in mind, there are two columns here. The column on the left is when we have the generator connected to the generator port. So being below 40% will start up the generator, let it run, qualify the signal, and then start using it by importing that power through the generator port. If you had a non-standard setup and you were coming through the grid side with a transfer switch, you would use the column on the right because your generator would then be connected on the grid side. So keep that in mind. The 50% here would send a two-wire signal to start when we're on the grid side. Well, right now we're focusing on the standard setup with a generator coming in through the gen port. Now, Daniel, there's a generator exercise cycle day and time, and our generators have a built-in cycle, right? When do our generators exercise themselves?
April Fool's Day. Oh, I'm sorry, that's the burn off. There is, it can also be sent up to the weekly to do that. And that brings it back. Nathan and I are really energy storage experts, but we have a team of generator experts. And I just want to bring up that point here. Andy's asking a great question. How often do you need to do a service call to adjust the valves on a Briggs & Stratton generator? How many hours of runtime? And I thought I knew that question, but as we were sitting here, I was able to text and message Andy Renner, who's one of the experts on the generator side. He says every 100 hours of runtime or annually, whichever comes first. And I think Andy's on here too, because he said that it's Tuesday at 2 p.m. for 16 seconds is the exercise. Yep. So reach out to us. We're experts at both. And if Nathan and I don't know it, we can get a hold of somebody.
Yeah, and
Thank you, Andy.
that was one of the few things that I have picked up from Andy's trainings is that exercise cycle at Tuesdays. Also, if you want to disable the Solarc from running an exercise cycle, I think Daniel was probably about to tell you that just disable that by setting the hours and minutes to 0. If you need to test your two-wire signal to start and you've just finished your installation, check that Gen Force button and then click OK. That'll allow you to start up the generator, test to make sure the batteries are charging, etc. And then if you uncheck that box and click OK again, OK is save on the Solarc menu, then it'll turn off that generator. Now, keep in mind, some of you might be looking at that screen and saying, boy, 100 amps of charging or 60 amps of charging. Man, my generator is not even capable of 60 amps of continuous charging. Well, those are amps DC. Okay, so that is the amperage coming into the batteries. That is amperage provided from the Solarc. 60 amps, I like to use the example that the battery charger is normally running at about 50 volts. It's really running a little higher. It runs up to 56 volts. But at 50 volts times 60 amps, that's 3,000 watts, right? So you really, when you're working between AC and DC, it's a good idea to kind of work in watts. So current times voltage gives you watts, right? And 100 amps there does not mean 24 kilowatts. 100 amps DC at 50 volts would be about 5,000 watts of charging.
And given that fact right there, Nathan, that again, great questions today. Patrick is asking, how long will it take a 13 kilowatt generator to charge three 6.6 batteries? How long will it take a 13 kilowatt generator to charge close to 20 kilowatt hours of storage?
That's a great question, and I'd like to address that with the settings on the right of the screen here. So if you have a 13K generator, you can limit the amount of power that is being pulled through the Gen 4 port under Basic Setup Advanced. So we can limit the gen power to 13 kilowatts. Now, keep in mind, the generator will have to cover the loads when the batteries are charging, right? Unless you've got some solar in there. But let's just think of a system where we only have a generator and we have loads in the house that need to be covered and we have batteries that need to be charged. So I would say I would not exceed 10 kilowatts of battery charging, even for my home, right? Leave at least 3, maybe 5 kilowatts of available power for the loads in the house when you're doing battery charging. But setting that limit there will allow the inverter to slow down battery charging as loads come on and go off in the house. So let's use the example where we can do 10 kilowatts of charging, right, for a 20 kilowatt hour stack. Well, it would take 2 hours to fully charge up a stack from 0 to 100%. Now, typically, you're not going to be all the way down at 0, right? You're going to start your generator when your batteries are at 30%. So going from 30 to 100% is about 14 kilowatts of kilowatt hours of energy. If you're delivering it at 10 kilowatts, about an hour and a half. So great question. And that's one of the things you can do. You can undersize your generator if you've got the battery system there. So just like a Prius car doesn't have a big gas engine, it's got an electric motor in addition to the gas engine so that you can deliver a little bit more. Now, I do want to mention on the previous screen, we talked about signal to start. And we said when the batteries are below 40% and there's no grid, so when those two conditions are met, the inverter is going to send a signal to start. The yellow condition there on the grid means that the grid icon there turning yellow means that the grid's no good, meaning either the signal has been disqualified because there's some problem with the grid signal, or it's just not present. And so if the batteries are below 40%, now unfortunately on the screen you see the batteries at 64%. I did have to set my percentages high just to get a picture that we could take here. I'll have to redo these pictures, but if the batteries are below that percentage, the signal will come on and you see that dashed line running from the grid icon down. That means the signal has been sent for the generator to come on. Once the generator comes on and the inverter sees a signal on the generator port, you'll see that that symbol show a generator there instead of a grid icon. And at that point, you see power flowing from the generator into the inverter, 2 kilowatts there. You've got loads being supported. There's also solar that's there on the screen, and that's feeding the batteries. So you will see those signals on the inverter screen. You can also see it in the app. What if we want to connect a generator on the grid port? So we talked about this at the beginning. We've got the ability to bring a generator in on the grid port, but if we're a grid tied system instead of off grid, we're going to have to manage whether we have the utility coming in on that utility port or we have a generator, and we do that with a transfer switch. So earlier it was asked about load management with our Symphony Choice transfer switches, and we can do that. Now that load management is based on what, Daniel?
Power.
Yes, power, right? So the load management modules that you'll get with our transfer switches will come on and off based on how much power is being pulled from the generator. Now, if you've got a slightly undersized generator and you're worried that large loads, in addition to battery charging, right, is going to take you over your power limit, having control modules that will drop off big loads like the air conditioner when the batteries are in a charging cycle, right, can prevent that generator from being overloaded. So you could use load control modules there to limit how much power is being pulled. Additionally here, so we're coming in on the grid port, there's still the two-wire signal to start. So just because the grid goes down doesn't mean the generator is going to start up. What will happen? Well, the grid goes down and we're going to run off what, Daniel?
Oh, the generator. You see the
So
transfer switch.
the
Yeah.
batteries first.
Oh, yeah,
Right?
yeah,
Yes, the
yep.
batteries
Thank you.
first. And then, right, if the batteries get low enough, then the generator will come on. And so we're going to show you in a second. We are showing here that if you have a generator on a transfer switch, so first off, this is just a generator on a transfer switch. Notice it keeps the generator port open. And for some homes that already have, microinverter solar arrays on their roofs, we might do what's called a retrofit. We come in there and those microinverter arrays on the roof don't give you any kind of backup power, right? If the grid goes down, so does your solar. But if we come in with a system like this, we can do what's called AC coupling, and we can bring in those microinverters to the open gen port now. So you can still have AC solar and a generator on your system at the same time. And if there's sun available, the AC coupled solar will power loads, and if there's extra, it'll charge the batteries. If that AC solar is not available because there's a storm or it's the evening time, the generator can come on and charge the batteries. And we're also showing, what's that Symphony 250 amp line voltage module, Daniel? What's that do?
That is one of our load control modules. In this example, though, we're using it to not as necessarily going to limit it power. It's automatically going to cut off as soon as it sees that generator start. Andy's asking, why is there a neutral ground bond on that backed up loads panel?
So we're looking at a neutral ground. This is not a backed up loads panel. This is the main service panel of the house. And so I'm thinking to myself,
And I'm hoping Andy will chime in here. I would
Yeah.
assume that it would be at the point of first disconnect.
Yeah, that's what I was thinking too, that, this is right out of the Solarc manual, and I don't want to make excuses here, but it should be right after the meter at the first point of disconnect, which I believe should put that neutral ground bond inside the transfer switch.
And Andy's saying yes.
Oh, great. Good. So good, Daniel. Thanks, or Andy, thanks for catching that here with us. If we have the generator on the grid port, there's a couple of settings that we need to hit in the Solarc manual. One is under the grid parameters setting. We just want to let the inverter know, hey, we've got a generator connected to the grid input. So look out for a generator signal. Now, a generator signal will look a little bit different from a grid signal. You'll see some more fluctuations in the frequency, etc. And so do have that box checked. The same thing as before, we have to disable the auto main sensing in the generator. So I know we've got it there. It's in the standard position it normally would be. And even though we're using a transfer switch, we don't want it to come on when the grid goes down. We want it to come on when the batteries get low. So now with the transfer switch bringing the generator in through the utility port, we're going to use that grid charge column to set our two-wire signal to start signal. That's going to come on at 50% in the example I've got here. And the battery charging here, we're looking at 100 amps. That's DC charging to the battery. And so those are the settings that you can see on the screen there. So again, when you have the generator on the grid port through a transfer switch, or because you're off grid, you use that column on the right there. So anytime the batteries are below 50% and there's no grid present when those two conditions are met, the two-wire signal to start will start up the generator. And after that generator signal gets qualified and the transfer switch kicks over, you'll be using generator power, and that will initiate a charge cycle on the batteries. Again, you don't need to use 50%. This is just an example. Okay, we can also come in and set our generator exercise cycle. We already covered this a bit. We could also disable it by putting the zeros in for the time and the hours and the minutes in that setting there. And then if we want to open up, now the default on a Solarc, and this is something you have to program, the default on a Solarc does not come with expected values you would want on a generator signal, right? So this connect time, so the normal connect is when you're already connected to the generator. You'll see some variations in frequency in terms of high and low if you're coming in through the grid port, right? And what this does is this actually controls the AC bus acceptable parameters for the inverter. If we get outside of this normal connect range, and the numbers that are on the screen here are not regular, I would normally set this around 220 to 250 volts. If we get outside of that, or if we get outside the 57 to 62 hertz frequencies there, the inverter will drop the signal. And it will not reconnect that signal until you're within the reconnect parameters that are shown on the screen. Again, those are not values I would typically use. You want to reconnect to be a little bit tighter than the normal connect. And then that reconnect ramp rate will start to load up the generator once we've reconnected. So under the grid selection, you have the ability to make some of these changes. I don't think I have a slide on it, but also under the grid selection, if you are off grid, you can change from a 1741 SB, which is a UL standard. If you don't have microinverters, you can change from that to, I think it's a general standard, I think it's called, Daniel, and then it allows you to open things up even more. So when we are connected to the grid, we do need to maintain tighter tolerances. Daniel, what are we looking at here?
Make sure that the generator isn't an automatic. Remember that either the inverter or the generator can do their exercise cycle. We usually suggest leaving it up to the generator. Make sure that these generators are approved for unattended operation, right? They're going to have safety checks in them to shut themselves off if maybe the oil goes low as well. And additionally, you can still manually start and stop the generator. Keep in mind, if you're working on a generator, hit the prime move or disconnect, so it's not going to start on you if you got your hands in there.
Yep. And Daniel, if you did want to start up that generator when you're doing your testing, you just hold down that start button for, I think it's 2 seconds, and that generator comes up. I think if I'm wrong, Andy is going to correct.
Andy Renner, yeah.
Yeah. All right. Great. So I appreciate that, Daniel. I do want to share a few things in terms of the 6.6 battery, what it looks like, how the installation goes, etc. Now, what you see on the right is that the battery is stacking. You're looking on the left at a floor mount example of the stackable 6.6. So that's a 20 kilowatt hour battery pack. It will typically last a whole house somewhere around 8 to 10 hours, right? If it's a house like mine, which doesn't use a lot of electricity, it could last up to 24 hours. So my home typically uses less than 20 kilowatt hours a day. And this would cover my home for a full day. Now, you can also do multiple stacks of batteries. And one of the nice things about these batteries is how quickly they assemble. And so you're seeing a marketing kind of GIF on the right side of the screen with it coming together. It really does stack like that, but there's a little bit more to the installation. We do have brackets that hold the battery to the wall so it doesn't tip over, or in the event of something like an earthquake or somebody standing on it, prying on it, right? We want to ensure that our battery is going to be safe. Now, that being said, don't stand on the battery. But you will have some wall brackets that I'm going to discuss in a minute. Some nice features of the battery. All of the battery modules have LED lights in them, and those indicate that the battery is operating in normal normal mode, as long as they're not flashing. If they're flashing, could be something like a firmware update, or it could be that the communications cables got connected wrongly, etc. There's status LEDs at the top too. Think of that as a fuel gauge. There's also a illuminating button, illuminated power button in the center that you can see there. Now the gold-plated connectors that you see there, that's Briggs & Stratton's rapid stack connector. And what that does is it allows all of the battery communications and power to be connected through those press fit pins. And that means that there really is no wires between the batteries. It's just an easy installation. And these batteries go together. I really love this battery. I'm not saying that because I'm a Briggs & Stratton employee.
We both installed
of
them.
Yeah, we've installed them. We've used them. And it goes together so easily and so quickly on a job site. We're talking about 30 minutes to get a battery system up and on a wall, or stacked on the floor. It also uses LFP battery chemistry. It's got improved electrolyte, allows it to charge and discharge fast. That means a lot of power out of a battery, right? So you can get plenty of power out of this battery. A single battery stack like that would do 14 kilowatts of continuous power. So it's a high charge discharge rate at 75%, 0.75 charge rate. That means it would be charging in about an hour and 20 minutes. Charge and discharge cycle, we can get 4,500 cycles or more, right? If you slow down the charge rates, you'll get even more than that expected. Now, of course, all of this depends on how a battery is treated, but 6,000 cycles, Daniel, that's 17 years?
Close, yes.
Close to 17 years. That's at 100% depth of discharge. And so if you limit your depth of discharge, you can expect more lifetime out of your batteries as well. But a lot of cycles there, and this comes with an unlimited number of cycles in your 10-year warranty on it. It's outdoor rated. You could mount it on a wall. You can mount it on the floor. The bases here are the same price. I think they're $100 or $120 or so for the base units, and you can wall mount this battery. I do want to point out we've spoken, and we only have about 5 minutes left, so I want to save time for questions. We've spoken a lot about our newer battery, but there are a lot of customers that are doing lead acid replacements still. And a lithium battery, if you look at levelized cost of energy, right, you get a lot more usable flow of power and energy through an LFP battery than you would through lead acids. And Daniel, I mean, you've talked about in your off-grid talks about how you like that Phi battery.
Yep, exactly. You don't have the communicating, maybe got an old Xantrax or old Trace or something like that. And we still additionally make 24-volt versions of that far left battery, as well as a 12-volt version, which we're not showing here on the screen, the 1.4.
And the 48-volt option as well. So 24, 48 on that Phi battery. The Amplify is a communicating battery. It's not outdoor rated, but we can put it in weather-proofed cabinets as well. And that comes with a 15-year warranty. And a 4.98 kilowatt hour battery. That's a wall-hung outdoor rated battery as well. And then if you are not aware, we do make high voltage batteries as well. So if you're in commercial and industrial, or if you get an opportunity to bid on one of those jobs, reach out to our team. We might be able to help you with that integration. Daniel, we're going to talk through a little bit about the generators here. We don't have a lot of time.
And this slide right here is actually speaking to Patrick Everts asking, I believe you're asking, can these generators be the emergency standby units, or do they need to be certified for continuous use? So we have two essential warranties a little bit. Our 18, 22, and 26 air-cooled generators have what's known as non-emergency certification. What that means is that as long as they have another source of power. So if we are at a home that has a solar, that has a 6.6 stack of batteries, yes, we will cover the warranty on the generator as a non-emergency use. And they do change the warranty a little bit. It goes to a 1,000-hour warranty runtime, as opposed to the year warranties that you would see on some of the other ones. So absolutely, these also can be used in demand response, where the utility can actually tell these things to start up as well. Next slide, please. So some of those were, although we do have additional inverter options, All of these are either propane or natural gas. We have a unique feature, NG Max, which allows you to run the 18 or the 22. Whether you're running on propane or natural gas, you're going to get the same amount of power out of these as well. Next slide, please. And we got a bunch of questions, so we're going to finish this off, and then people need to jump off. Go ahead, but a lot of great questions
we still
here.
have 5 minutes left.
Yeah.
Let me just point out, in addition to the air-cooled line of generators that we have that are popular for residential use, we also have liquid-cooled generators going all the way up to that 200 kilowatt unit on the right.
Yep.
We're going to be providing these slides. Again, you can reach out to our generator team as well. And Daniel, we did want to talk a little bit about installation locations. I know most generator installers know this, but maybe some of the solar installers on this call might want to learn a little bit more about this. And so
yeah, and I would say on here, 5 feet from openings, you'd think that would be a door. You'd think that'd be a window, but also there's soffit vents, that dryer vents, additionally vents in the basement. You got to keep them away because we don't want to introduce carbon monoxide into the home as well.
Great
or set that tree on fire. Fuel sizing, Andy runs a bunch of trainings as well, and we'll have opportunities to do that. I would say, Andy, if you're still listening, undersized fuel lines is probably one of the biggest problems that a lot of times these are running into. So understand that there's not a lot of pressure in some of these gas lines, and that if you are going to be doing these, we have tools to help you size some of those fuel lines. If you go to the next slide,
and once you've installed those lines, take your manometer and test, right? You should be testing to make sure that you have the right levels of pressure on the natural gas and the propane. Now, the propane is obviously, if you got a propane tank there, it's going to depend on temperature and flow rate, so you can have things go down. But make sure that you've got that right amount of pressure on the natural gas line there.
And you're going to be able to measure that. Why? Because you're going to put a manometer port at the entrance into the generator. What we're showing here on the screen is a proper way to do a drip leg. And then additionally, you can see that flex line going into the generator is straight. It's not kinked. I will just say this, that although you're going to have maybe a certain number of run feet of pipe, every one of those valves, every one of those T's, every one of those elbows is introducing additional resistance to that flow of the gas. So it should be accounted for when you're sizing your gas lines.
And keep that in mind as well. I know that there's a move to use corrugated stainless steel tubing in a lot of these connections, when it's buried connections as well. Well, that's a different amount of resistance in the flow rate of your gas. So keep that in mind and utilize our tools for sizing your lines. We have plenty of training on installations of generators. Daniel and I know a little bit, but we certainly are not the experts. You want to talk to guys like Mike Strawn and Andy Renner, and you can access their learning content through the Briggs Stratton Power Academy. So if you don't have a login for that, you can use this QR code that's on the screen and sign in. And again, I know, Daniel, you said we had a lot of questions. If you are here for your NABCEP credits and you would like those continuing education credits, send an email to energystoragetraining@basco.com with your name as it should appear on the certificate, and we'll get those certificates issued and sent back to you after checking the logs. So Daniel, let's answer some of these questions.
Yeah, let's go quickly back to Andy Malone, who asked about the neutral ground bonding in that, and Andy Renner, who's with us on our team, mentioned the neutral ground bond should be made in the whole house transfer switch in that scenario. That's your first point of disconnect, since it has a service entrance breaker built in. Then the customer's load panel off of that inverter, the solar converter, becomes a sub panel, and you would have to separate the neutrals and grounds there. Additionally, Nathan, the other subject is you just press the manual button. There's no need to hold it down.
Great.
WardFlex, Rego have some great apps to help you with some of that pipe sizing as well. Patrick's asking, what are the dimensions of the battery?
So the battery is about 7 inches deep. I believe it's 28.5 inches wide, and it's 60 inches, almost exactly 5 feet tall. So once you have it up on the base, it's 5 feet tall. about 2.5 feet wide, just under 2.5 feet wide, and 7 inches deep. So it's
Uh,
pretty compact. We've certainly packed the cells in there nice and tight. And it's a powerhouse. Like I said, 14 kilowatts out of one of those stacks. We see a lot of installations with dual stacks as well. Keep in mind, you need to install them 36 inches apart.
Great. Which Briggs & Stratton generator will be able to be max on a 19.2 kilowatt terminals?
So again, I mentioned, I mean, you can certainly install different sized generators. I don't think we make the 20K anymore, and I believe it's the 22K.
Yeah.
You would be able to supply that full 80 amps continuous max through the Solarc 80 amp generator port. And
Yeah,
of
and
course,
Andy
any of the
Renner's
generators you could max out on the utility port. Daniel, sorry.
yeah, Andy's mentioned it's a 100 amp breaker on that 22 kilowatt. Patrick Ever asks, so when the batteries are charging, they cannot be supplying power to the house?
So yes, when the batteries are charging, so a battery cannot be charging and discharging at the same time. And so if the generator is running a charge cycle on the batteries, it also needs to be covering the loads in the house. Now, if you had DC solar on the house, that DC solar could be used to potentially cover the loads on the house. But if the charge cycle has been initiated, that means that the solar wasn't strong enough to cover the loads of the house because the battery was discharging to get down there to signal the generator to come on. So typically, Daniel and I try to program the the generator charging cycle of the batteries to be at a value where the generator could handle the charging and cover the average loads in the house when they come on and go off. By limiting the power coming in through the gen port, you can allow the inverter to control the charge rate. So if you go too high on your loads in the house, it'll just reduce the charge rate on the battery charging. But yeah, good question. You can't be charging and discharging the battery at the same time. So unless there's solar, that generator needs to be charging the batteries and covering the home's loads.
Andy Malone again mentions, California requires the seismic valves on the gas for emergency shutoffs. I've had a love-hate relationship with some of those over the years. If you happen to hit it with the garbage can, or if there is an earthquake, it doesn't shut off. But great point. Andy additionally asked Nathan, when powering up the battery stack for the first time, should we keep the DC breaker in the Solarc inverter off? Or does this not cause any issues if it is switched on before turning the batteries on?
I have to apologize. I was I was thinking to myself about when you do buy those gas valves here in California that they come with that kind of auto stop. So what my understanding of this question is that when you are first turning the Solarc inverter on, or first turning that battery on, what do you want for
Yep.
the DC breaker on the Solarc? And so here is my recommendation for your turn on cycle. With everything off, turn the battery units on first with the DC breakers off, the load disconnect in the Solarc off, everything off. So turn the battery on first. Once that battery comes on, then you will switch on the DC breaker in the Solarc. By providing power to the Solarc, right, that can start it up. Now we're going to have the PV off still. So the battery is the first thing that comes on. Once you switch on that DC breaker, you can hit the start button on the side of the Solarc, which will bring it up and allow you to program. So before I turn any loads on out of the Solarc, etc., I get the programming settings set in the Solarc. We program for the generator, etc. And keep in mind, when you're doing this programming, if you don't have a disconnect handy near you, you want to make sure that the disconnect on the generator is off so that a two-wire signal to start doesn't start up the generator and bring power into that inverter. So you want to make sure that you've got everything disconnected. You finish your programming with the batteries there, and then you can turn on the load output of the inverter, turn the disconnect for the grid, bring that back in, and test your generator, etc. So batteries on first, then disconnect.
Yeah, so that's why I kind of, batteries always on first and batteries always off last if you're, say, shutting down the system as well.
Exactly. Good point, Daniel.
Patrick is asking, how can you prevent AC coupled PV from backfeeding a generator connected to the grid port via an ATS if PV production is higher than load demanded during a grid outage?
That's a great question, and I was going to try to hit this slide again. So if you mentioned a transfer switch, if you've got one of our transfer switches, what we're showing here on the screen is a lockout module. So typically generator and solar are not going to be, AC coupled solar are not going to be on at the same time, because if the AC coupled solar is running strong, it would be charging your battery, and your battery would not be low enough to bring the generator on. So that would be my first answer to your question. If the AC coupled solar is higher, right, than the loads in the house, the battery would already be in a charging state and shouldn't be telling the generator to come on because it's getting low. However, I do realize that clouds can come over and then go away, right? And so you might have a small amount of AC coupled solar because you've got cloud cover. Your generator's running and charging your battery, and all of a sudden the clouds move, right? And your micro inverters come back on, cover the loads of the house, and potentially backfeed your generator. So a great way to stop that is to use one of these lockout modules. I think they're about $100, $120 for one of these lockout modules. It prevents the AC coupled solar from being on at the same time as the generator. So now it's an either or system. So either the generator's on and charging the batteries, or the AC coupled solar's on and charging the batteries, but not both at the same time. And now you've protected your generator from ever getting backfed.
Yep. And it's the transfer switches normally don't come with Symphony Choice. You would have to buy the device for the transfer switch in the Symphony module as well. And Andy Renner says, they will open up upon loss of utility power, set the module dial to either 9 or 10, which will lock it out when the generator is running as well.
Great. So that's
Scott,
the details about how to program the transfer switch to lock out the Symphony modules.
just a couple more left. Thank you everyone for sticking with us. Scott says, so a generator can both power the home and charge the batteries in a grid outage?
Yes, absolutely.
What is access in Rule 21? We must have shown it on one of our previous slides. What is the access cabinet?
So our access cabinet is a cabinet that'll hold up to 12 of our batteries. You get 40 kilowatt hours in a single battery cabinet. It is UL 9540 certified, and it pairs nicely with the SolarX as well. Rule 21, I'm missing the context here.
That's specific to California, and it has to do with the interconnection and how the inverter behaves when it's connected to the utility grid. Whether or not it helps support the frequency and the voltage of the grid. So the SolarX, I believe, is Rule 21 compliant.
Okay, and that's news to me. I'm not as familiar with that. I also want to mention that the SolarX have PCS control, and so if you do decide to use the SolarX to feed a sub panel, or if you use a smaller version of a SolarX, you don't need to limit yourselves to feeding the SolarX with a 40 amp breaker for 200 amp service or a 20 amp breaker for 100 amp service. Right, so if you're using other SolarX other than the 15K that we're showing you with a 200 amp pass through, you've got that PCS certification. That's one of the things that we look for when we're trying to pair with inverters for communications with our batteries.
Last question, and it's a specific one. Chris is asking, I have a 360 amp service serving 2 buildings. The SolarX can only be on one. So I installed a transfer switch, so when grid service is down, the second building is served via a house circuit. I think that's more of a comment than a question.
Okay. Yeah, and I think he might have been sharing it with somebody who had asked a previous question.
A little earlier.
Yep.
Andy's, again, thank you, Andy Malone. Do you know the max amp rated lockout module that is available for preventing the AC coupled solar from backfeeding the generator?
So my suggestion, so 50 amps for us, and most homes are not going to have more than 50 amps unless they have more than 200 amp service. The limitation for backfeeding to the grid would be 40 amps on a 200 amp panel unless you have a specifically designed solar main load center, right? Where you'd have, because of the 120% rule, you can only feed a 200 amp breaker so a 200 amp panel at 40 amps, unless you have bus bars that are oversized in there.
Or you derate the main.
If a 50 amp module doesn't work for you, you can, of course, run two 50 amp modules for more than one, string of AC coupled solar. So I think, 50 amps, is that around 15K, Daniel? I'd have to do the math, and I think all of you can do the math in terms of, I think it's
12.
12K. Yeah,
12.
12K.
And we're gonna be coming out with some larger modules, to support hot tubs and the like very soon.
Thank you. All right, everyone. I really appreciate the questions, and we've enjoyed this conversation with you. Hopefully, we've learned something. I always learn something when these questions come in. So thanks, everyone, for contributing with your Q&A. We'll get your NABCEP certificates issued to you when those emails come in. Again, energy storage training at basco.com. Thank you, and we'll get these slides out to you in addition to a recording in case you would like to share it.
Thank you, Nathan.